Good morning, everyone. Today we're going over Unit 2, Lesson 1, Linear and Quadratic Relations. So this unit is going to focus on looking at polynomial functions, in particular their graphs, and different key characteristics we can tell about those. But first we're going to review what we already know about two types of polynomials. So we're going to review what we know about linear relations and quadratic relations. So let's start with linear relations. So what do we already know about linear relations? The equation of a line, y equals 2x plus 5. So what do we know about this equation? Well, the graph of this equation is a line. What is the degree of this relation, a linear relation, meaning what is the highest exponent on x? So if we look, the highest exponent we have there is just a 1. And one of the differences are constant. With linear relations, our first differences are constant, which tells us our slope. So when we compare consecutive y values, those are our first differences. Those are constant, which tells us our slope. There's a couple different ways that we can represent a line. So one of the equations of a line is in slope Y-intercept form, where b is our y-intercept, and m is your slope. You could also represent it in standard form, so ax plus by equals c, and your slope in this case is a negative b over a. That would represent our slope if the equation was in standard form. So how can we graph a line? We can graph a line using a table of values. So that's where we set up our x and y, and we sub in some values for x to find our y values. You could also use your y-intercept and your slope. So you plot your b value, which is your y-intercept, and then use your slope to plot additional points. Or you could plot your x and y intercepts and connect the dots. So for your x-intercept, you're going to sub in y equals 0, and for your y-intercept, you're going to sub in x equals 0 into the equation and then solve for y. All right, to make a line, you need at least 2 points, and then you can just connect those 2 points and you have a line. So graphing a line is not too difficult once you can identify 2 points on the graph. So that's linear relations. So what do we know about quadratic relations or a quadratic function? Well, we know that the graph is a parabola. The highest degree on a quadratic function is 2. Let's just write a quadratic function since we don't have one. So a quadratic function looks like this: x squared plus 4x plus 3. That would be a quadratic function. So our highest degree is that 2. Which differences are constant in a quadratic function? Our second differences are constant. So we calculate our first differences. Those will all be different values, and then we compare those first differences to calculate our second differences, and those should all be the same. Okay, the equation of a quadratic function can be written in 3 forms. We can write it in a vertex form. So f of x equals a times x minus h squared plus k. We can have our factored form, g of x equals a times x minus s times x minus t, or we can have our standard form, h of x equals ax squared plus bx plus c. So a couple of things to recognize about these forms. Notice that they all have this a value in the front. Okay, and the a value stays the same in all forms. So it doesn't matter if we're trying to go from one form to another. Like if we're trying to go from vertex form to factored form, our a values are a value. It does not change as we go from one form to the next. If we look at the characteristics of a quadratic, we're going to label some information on this graph. So first of all, the direction of our opening. Okay, that's one thing that we have to look at. So the direction of our opening is based on our a value. So if a is positive or greater than 0, we're going to open up. If a is less than 0, or negative, the quadratic is going to open or point down. Okay. Your x-intercepts and your zeros, those are found from factored form. And those are represented as s and t. So your zeros would be s0 and T0. Those would be your zeros. Okay, so if we look over here on the graph, we could label that these are our zeros. All right, there, where does the quadratic cross the x-axis? Your vertex comes from vertex form of a quadratic. And that is found from your factored, or your vertex form, HK. So we can identify that on our graph as well. So this is our vertex. Our vertex is the turning point of our graph. And it's either going to be a maximum or a minimum. So write that over here. Maximum or minimum. Okay, your axis of symmetry is this vertical line that cuts the parabola in half. So we're going to label this axis of symmetry. All right, and the axis of symmetry is found by either averaging our zeros. So the x is going to be equal to your zeros, or s plus t divided by 2. Or it's just going to be the x value from your vertex if you know that. Okay, so this is from vertex. And lastly, our y-intercept is where does the graph cross the y-axis. And we can see that here it says 0, c, and that c comes from the standard form of a quadratic, ax squared plus bx plus c. Whatever that constant is, that represents our y-intercept. All right? So those are some things we can identify depending on what form we're in for the graph of a quadratic. So we're going to look at these 3 different forms now. Okay, so if we're in vertex form, we're going to go through all 3 forms and talk about which points on the graph we can identify or how we can identify them, in particular our vertex. So in this form, the vertex is always at the point HK. And you'll notice that H, when we pull it out of vertex form, is going to be the opposite sign of what's in the equation. And remember, our vertex form is y equals a times x minus h squared plus k. So our a value is going to tell us the direction. I'm going to write that another. Our a value is going to tell us the direction of our opening. And it's also going to tell us, which we've learned in previous courses, our step pattern. So our step pattern is usually 1, 3, 5, but we take our a value and we multiply it by those values. So 1 times a, 3 times a, and 5 times a. And I'll show you what I mean with this first example. So if we look at our first equation here, we have f of x equals 3 times x plus 5 squared minus 2. So our vertex is going to be the 5 and the 2, but remember we have to take the opposite sign on the 5, so it's going to be a negative 5, negative 2. Okay, our a value is a positive 3, so that's going to tell us that it opens up. And our step pattern is going to be 1 times our a value, 3 times our a value, and 5 times our a value. So 1 times 3 is 3, 3 times 3 is 9, and 5 times 3 is 15. So that is our step pattern. Okay, next example, if we wanted to look at our vertex. So our vertex is, and we take it right from the bracket, so that minus 6 is going to become a plus 6 in our vertex. And then we have nothing being added here, so we could say it's a plus 0. So our vertex will be at 6, 0. Our a value in this case is a negative 1/2. So it's negative, so we can say that it's opening down. And if we want to identify our step pattern, so those steps we take from the vertex to graph other points, we are going to take our A and multiply it by 135. So we have 1 times a negative 0.5. We'll do 3 times a negative 0.5. And we'll do 5 times a negative 0.5. So our step pattern will be negative 0.5, and then 3 times a negative 0.5 is a negative 1.5. And 5 times a negative 0.5 is a negative 2.5. Okay, so you'll see examples in your practice problems of identifying those things as well. Okay, so that's what we can identify in vertex form. In factored form, we should be able to identify our zeros and our vertex. So in this form, you can determine the zeros and the vertex. First, we're going to find the zeros, all right, by setting each bracket equal to 0 and solve for x. So each bracket equal to 0, and then we're going to solve for x. Then we're going to find our x value of our vertex, which will just be the midpoint of our zeros. And then finally, to find the y value of our vertex, we're going to sub back in that x value that we just found. So let's give that a try with this first one. So we have our two factors here. Gotta grab the right tool. We have our two factors. We're going to take those two factors and we're going to set them equal to 0. And then solve for x. So we can bring that 1 over by subtracting it, and we can bring the 3 over by subtracting it. So these are our zeros. So that's step 1. Step 2, we're going to find our x of our vertex. So this is our x value of the vertex. Okay, and the way we do that is by averaging our zeros. So we're going to take our zeros, we're going to add them together, and we're going to divide by 2. So negative 1 plus negative 3 is a negative 4. Negative 4 divided by 2 is a negative 2. So that's the x value of our vertex. Now we have to find the y value of our vertex. So this is the y value of our vertex. So we will sub that x equals negative 2 back into our equation. So we would say f of negative 2 equals negative 2 plus 1 times negative 2 plus 3. Negative 2 plus 1 is a negative 1, and a negative 2 plus 3 is a positive 1. So negative 1 times 1 is negative 1. So therefore, the vertex is negative 2, negative 1. Okay, let's just set up the next one, and then you guys can work through that. Pause the video. So we have our two factors. Don't be confused that you can just say that our 0 is a negative 1. We have to set that whole factor equal to 0. 2x plus 1 equals 0, and 2x minus 5 equals 0. Now use algebra to figure out what x is, what are your zeros, and then work through finding your vertex after you find your zeros. Pause the video and try that now. Okay, so there's your solution for the second example of finding your zeros in your vertex. The last form that we have for a quadratic relation is standard form. In this form, the y-intercept is always c. So the standard form of a quadratic looks something like this, and our y-intercept is going to be 0, c. Okay, the zeros in the vertex can be found by factoring, which we are going to go over factoring in the next lesson.